What's up guys, Shawnthebro here, and today we're going to be going over multiple respawn platforms, revival platforms in our Super Smash Brothers / Platform Fighter tutorial series. The reason for this is because if we had, we did the episode on revival platforms, and if we have all the characters in this multiplayer game respawning in the same way, you sit on a revival platform and it brings you down to, the middle of the level or whatever. While that method is good, if you have multiple characters respawning at the same time, getting KO'd at the same time, then you could have some graphical issues where they're overlapping, or you could have some issues where they don't actually move out of the way. So say, we don't have a timeout yet where we automatically kick players off the revival platforms, but say that the player gets KO'd, and then another player gets KO'd, and the revival platforms are on top of each other. Well, if you don't have a timeout, it could cause issues with collision and different things like that, depending on how you set it up. So we're going to have a simple episode today to take care of all those issues before they even come up. First of all, let's pretend I am this green guy here, and I get KO'd. I fall off the map. Again, we don't have a timeout, but you can see that the player is now on his revival platform at the center of the stage, and we set that up in the previous episode, so that's working as intended. Now, let's say that another KO occurs around the same time. We want the revival platform to be somewhere to the left or right of that. That way they're not directly on top of each other. It also just looks better on top of actual bugs that could occur. It actually looks better to have them separated anyway. So let's keep it going. This person also gets KO'd. And lastly, this player gets KO'd. There we go. So what I've done now is I've actually set up a little system here to randomize our respawn lanes. So basically we have these little designated spots on any map that could occur, and we could use them for our respawn platforms, but it's going to be randomized. Now, I'll show you how to make more specific methods if you don't want random, but let's do this one more time, just so I can kind of show you that it is random. Actually, I loaded the wrong map. Here we go. Jump off, center, and this time it's to the left, and they happen to all be to the left. But basically we have a default value that is the distance between revival platforms that we want, and then I have it based off of a random integer, determine if it's going to be to the left or right of this position. This way we can spawn them randomly. It also allows you to have the players come off at different points, or to potentially not be camped so easily by the other players. So let's get into it today. Now, I've already mentioned it a few times, but just to be completely safe, if you have not watched this series or any episode regarding the revival platforms and the respawning, you may want to catch up on that now before we get into it, because we are going to be using that stuff today. I'll leave a link right here in this icon in the top right corner if you want to check it out. I'll leave the entire playlist, and I'll leave just the respawn episodes. Alright, and otherwise we can go ahead and get started. Now, first things first, I'm going to add the character state enum to this platform fighter. We've done something similar in the fighting game tutorial series, if you're familiar with it, but the basic point of this is that we have different states that our character can be in. We have to be careful with this because the character can be in potentially multiple states at once. For example, I filled out some default states here: idle, moving right, moving left, running left, jumping, dead, and respawning. But some of these can be happening at the same time. For example, we could be moving right and then also jumping. So we have to determine what we want to be a state and what we want to be a boolean or some other identifier. And it's very possible that this will change many times throughout the course of the series, which is why I have not added all the possible states, and I have not differentiated this very much, because it's going to take some trial and error and us playing around with it to figure out what we really want to do here. This is what I've chosen for now, but feel free to put in whatever you want. The main ones we want for now are some sort of default state, like idle, that we're going to set the character to right off the bat, and then dead and respawning. And the reason that I'm setting this up in this episode is because if we have the If we know if the character is respawning or not, we can know what to do with the character. And that's how we can determine where we want to spawn the character, or how many characters are respawning if we need to know that, and basically how to set the character state to be invulnerable or intangible like they should be when they're respawning. Now, we don't actually do that in this episode, but we are going to be setting when the character is respawning or dead in this episode. So it's important that we set this up now. That way in the next episode, which will be the final episode for respawns for now, we will already have everything in place, and we will just need to focus on the logic for after the character has been respawned. So, long story short, in our character class, SSB template character.h, go ahead and make an enum. Make it look like this, but you can either add or remove as many states as you'd like here. Call the enum whatever you want. I call it eCharacterState, and you can give these names that you want to see in blueprints when you're looking at them. Alright. And then this is an enum, but we do need to make a variable that is basically an instance of this enum class. So we do need to make an eCharacter class, or excuse me, eCharacter state down below. So you can see I put it right below my timer handle. It obviously doesn't matter where you put it. And I've called it eCharacter state, character state. Okay. And that's pretty much good for the header file. Let's go to the CPP and set up some default values. So in the constructor at the top of the file, where I set all my variables, I do set the character state to be idle by default. Now, we don't have any sort of spawning intro animation or anything like that. However, if we did, and when we do get that, we probably will want to have a spawning state, potentially different from respawning, just flat out spawning. That way we know what animation to play. But for now, this is perfectly fine. We don't have that logic in place to deal with all that, so idle is good for now. And then I'm going to scroll down to my lose life respawn functions. Now, I made both these functions in the previous episode, or a few episodes ago, but all part of the respawn series. But we're going to adjust them a little bit today. Essentially what we want to do is when the character loses a life, we want to set their character state to be dead. And we want to make sure that they don't get out of this at a time we don't want them to. So before, in the previous episode, we were jumping off, hitting the death barrier, the little blast line, losing a life, and we were actually able to lose more than one life. Potentially we hit more than one blast line, or potentially we collided with the blast line more than one time before we respawn the player. So we're going to fix that issue now. It's important that we do, not only for the game itself, but for today's episode, just so it makes more sense what's going on. And we're going to fix this by using our character state that we just created. So essentially, we're going to add an if statement that encompasses all of lose life. And we can't lose life if the character state is dead or respawning. Now, if the character is already dead, dead is the state before they've respawned. So if they're already dead, they shouldn't be able to die again. If they're respawning, they shouldn't be able to die either, because if you leave the revival platform or attack off the revival platform, you will not be in the respawning state anymore. You'll go back to idle or whatever state it is that, you go into. So you won't be able to stay in respawning after leaving the revival platform. Thus, you shouldn't be able to die after leaving or while still in the respawning state. So we want to make sure that neither of these things are true before we actually do the functionality in lose life. And now, since we're checking that they're not dead already, we want to set them to be dead at this point. We're losing a life, so the character state is dead. These things are from before, but we're going to keep them. Basically, we do want to subtract a life here, but we also want to make sure the character cannot continue to move at that point. If they're dead, there should be no control over the character. Then we were updating the amount of lives on the HUD so that we knew if the player actually had lives remaining or not. If they had 3, now they have 2. We should represent that. And then if their lives were greater than 0, we still want to respawn them. We were resetting the damage counter, and then we were calling the respawn player function, which is a blueprint implementable event. So if we go to the SSB template character.h, respawn, is the function here that we were calling in the character. And then in the SSB template game mode.h, there is a respawn player blueprint implementable event with the player number, so we know what player to respawn on the revival platform that we're calling in here. Again, this was done last episode. I'm just catching you up because we're going to go use this blueprint implementable event now and adjust some things on it. So we're done with the code. Let's go into the editor and let's open up our game mode BP. Okay, and there's a few things we have to adjust here. Alright, so now in the event respawn player, we're going to basically be doing the same stuff that we were doing, but we're not going to get just a specific spot in the center of the stage this time. We're going to have a variable called current lanes that we will add to our game mode, and the current lane will basically control where we are going to spawn our revival platforms. You could make actual lanes and put them on your map, and that would work fine. But it's a little bit, it would be a lot of work because you'd have to set up the lanes, and if you want to move them apart, you have to move that for all stages. So instead, I'm just going to use actual math to determine a good distance between the revival platforms that I like, that I think looks good, and then we're going to randomly choose which one it goes to. So this is our respawn player. We were getting the player from the player number, and we were setting the character reference after choosing the revival platform spawn location. And the way this worked is we're getting the blast line data to calculate the center of the stage, and then bringing it a little bit below the top of the top blast line. That way we knew exactly where the revival platform was spawning. Now things are going to change pretty drastically in here. Everything that we have is actually still good, but we're adding a bunch of new stuff. And this is just specifically if we want to make it random. I will go over how to make it a specific manner that you want. But first, let's go to the game mode.h, or SSB template game mode.h, and add the current lane variable that I was referring to. Basically, I have an integer in the header file, and it says the next lane number to respawn a character in. And so when a character is respawned and a revival platform is active, if another character is trying to be respawned, it will just change. It will update the current lane to match the lane that we want it to be. In the constructor of the game mode, I set the current lane to be 0, and 0 will always be the center. Alright, so let's go back to Unreal. And let's take a look at what happened here. Now, if you compare this episode and last episode, you're going to see some familiar stuff here. You see we're making a vector, making a transform, and then returning that transform through the output node here. And that's actually what we're doing the whole time. We're just going to be adjusting the actual location that's getting created to change where the revival platform is spawned. So all of this stuff we had from the previous episode. But now we're going to adjust this a bit to make it work for the center and to the left and to the right of the center for these different revival platforms. The first thing I do is I grab our current lane variable. I check if it's equal to 0. If it's equal to 0, I'm basically going to take the unaltered center of stage revival platform. Current lane being 0 means that no other players are currently spawning here. They're not being respawned. There's no revival platforms out in play. The center slot is open. So the way this works is current lane, get current lane, and then equals, and this is equal integer. And then I drag this out into a branch. Okay? So if that's true, I'm going to show you these green lines as well as I can because I don't want this to be confusing, but quite frankly, I could not get this in a way where I thought it was all that neat. I think this looks about as good as I can get it. So let's be careful, but let's cover what we want. The only value that is going to change when we're referring to these revival platforms and where you would spawn if another player is already on a revival platform is the Y value. If we look at our level, in the bottom left hand corner there is this little axis indicator. So we have X is the depth it is closer to the screen or farther away. Z is the height, up and down, and Y is left and right. We only care about left and right in this case. So the X value and the Z value are going to be the same for all of these that we make. We are making 3 different cases. Again, the center, left of the center, and right of the center. So for all cases, X is going to be from the same X that it was last time. We're getting the X of the player start, which is just the depth, and because we want it to be the same. We want the revival platform and the spawn characters to be at the same value as we expect them to be. And we're always plugging that in for the X. You can see the bright green line here is going into X for all 3 make vectors. And the same is going to be for Z. We get the Z value from the top blast line ref. That's where we were getting the Z value, because that's where we want to spawn the revival platform. And you can see this Z also goes into the make vector for all of these. We do move the revival platform down, but there's no reason to change the Z at any point, because we're already doing that. We only care about the Y. So you can see the X and the Z both go into all 3 of these make vectors. That should simplify some things. Now the Y we were basically getting the left blast line, the right blast line, grabbing their Y values, adding them together, and cutting it in half. Multiplication instead of division, because it's a little bit faster in terms of coding. So we were getting the center of the stage, and that's what this value here is. This is Y. I'm going to actually pull this back so you can see that it's separated. So Y comes down here, and this is what I'm hovering over now. So you can see Y goes into one of the make vectors, but then it goes into these other plus nodes. So I'll explain everything here, but this is the path of Y. All right, so let's follow it. Let's follow it one at a time. So this is the same Y value that we had in the last episode. Again, this is the center of the stage. Let's follow the first path, the top path. So the top make vector here is the center of the stage. If we don't want to adjust it to the left or right at all, then we want to spawn it in the center. To do that, we only have to pass in what we already had, because that's how it was working in the previous episode. So we have our X value is being passed into it, and our Z value is being passed into it. Remember, that's happening for all of these. And the Y value is coming directly from the center of stage calculation and going to the Y value here. And that's why if current lane equals 0, then we are doing this one. Basically, if no one's respawning, spawn at the center of the stage as the location. Simple enough. At this point, these next 2 are very similar, with one minor change, which is just that the value we are multiplying by is either positive or negative. So this should be pretty simple. This is the Y value yet again, so we can follow it along and see how it works. Okay? This is still the Y value. We can follow it down to this plus node. So take a look at what we're doing. We're doing current lane times 200 plus the Y value. And we're plugging that into the Y value for this make vector. Now, look at how this works here. So Y is horizontal, right? And our current lane is going to be incremented every time that someone is respawning, every time there's a revival platform. So if there's a revival platform, then the current lane switches from 0 to 1. So 1 times 200 is 200 plus the center of the stage value. So if the center of the stage is at 750, then 750 plus 200 is 950. And that's what we're using as the Y value here. Now notice, if we keep following this path, we will get another current lane value of 2. If there's 3 players currently spawning, then the lane value that we need to spawn in is lane 2. 2 times 200 is 400. 400 plus 750 is 1150. So you can see how this works. If we have more players spawning, we're going to have more space from the center, and we will always be able to have our own revival platforms in our own space. Okay? We just take the result of this float plus float and pass it into this make vector. The rest is very, very simple. It is the X and the Z that is the same for all these make vectors. And this stuff is the same as the top as well. We have make vector goes into the location, the rotation and scale remain their default values, and then we pass the return value to the return node. Then the alternative, based on the way my map is flipped, this is actually moving to the left of the center of the stage. And this one's moving to the right. But it's the same exact algorithm. We take the current lane, we multiply by negative 200, and then we add the center of the stage. Then we pass that into the Y. Now that's good, but you're probably wondering how I pick that. So right now, we're just using a random integer. Literally, random integer. Right here. As the max, I set 2. If you hover over random integer, should tell you here in a second. There we go. Returns a uniformly distributed random number between 0 and max minus 1. So if I want 2 values, basically left of center or right of center, I need to put the max as 2 because it's 0 and max minus 1. So max minus 1, if max is 2, is 1. So between 0 and 1. All right, I have 2 options there. 2 choices. If I put the max to be 1 because you're thinking, oh, 0 and 1, max gets subtracted by 1, so it'd be 1 minus 1. You would only ever get the same value every time you use random if you had a max of 1. So make sure when you're using this random integer node, if you're doing it just like I am, where you have it random, whether it's to the left or right of the center, make sure you set the max to be 2. And all I do, you can check this numerous ways. You can check if it's equals 0, if it's equals 1, if it's less than 1, if it's greater than 0. I just happen to choose... I brought off this and said integer greater than integer, and I checked if it was greater than 0. Then, if it is greater than 0, I opt to go to the left. If it's not greater than 0, meaning it's 1, I opt to go to the right. Okay, so it's actually pretty simple. It was a little bit confusing because of all these green nodes since they're all floats, but it should be pretty simple to understand. Alright, so that's how, if you want to do it random. If you want to do it, you could do it other ways. You could have it to where it's always to the left, always to the right. Just don't do random. That's the only thing I'm doing differently here. If I always wanted it to the left, I would do this one. If I always wanted it to the right, I would do this one. I would have no need for this branch, and I wouldn't have a need for the other case here. I could just do this. If you want to have it so that there's no gaps in between, but it can be to the left or the right, well then keep track of where your lanes are. Specifically, keep track of, oh, this one's been to the left or this one's to the right, and make sure you only apply the offset to a spot that has not already been taken. There's a ton of different ways you could do this. I happen to like the random method, but you can still use this method as much as you want, and if you have questions about how to implement a specific one, let me know and we can cover it. Alright, and now that that's over, our Get Revival Platform spawn location is set. It still drags off and goes into the spawn transform, so we spawn the Revival Platform BP. Now the next 2 nodes are also the same. We're setting the character reference to the character that's spawning on it, and we play the start entrance animation, so we play the little platform being brought down into the scene. And all this stuff is still the same too, where we're changing the location of the player and the platform. The only 2 things we have to do now are, after we've spawned the platform and after it started going down, I go ahead and drag off the character state, drag off of the character and set the character state to be respawning. So at the start of this function of event respawn player, we do players get and use the player number, and then I drag the player down below here. And that's how I set character reference and different things like that. All I do is drag off of it, set character state, just like this, and I set it to be respawning. At this point, we no longer are dead. We have actually moved the character to the platform, so I feel it's safe to say they are respawning. You could actually wait if you wanted until they were at the specific world location. I do it here because this is the point where we've set the character reference and we do know what is going on internally, so I think it's a good spot to do it. But it is up to you. It does not really matter as long as you're aware of where you're doing it. Lastly, I have a function call here, adjust current spawn line. And this is where we're going to set what lane it is. And there's also a few ways you could do this. So the easiest way that I found was just to basically add to the current lane. I mean, every time there's someone respawning, add to the current lane. You could also check and see how many players were respawning and just set the current lane equal to that value. But regardless, we need to change it. So right after I set the character to be respawning, I adjust the current lane. That way the next character that can spawn will be in the right spot. So, add function. I called it, again, adjust current spawn lane, and then go inside of it. And what I do is I grab our current lane variable, I integer plus 1, basically increment it, but the reason I'm doing it this way is so I can check against it before I add to it, because I actually want my current lane to be less than the player length. So we have a bunch of different players. You know, we have 4 players, or we can have up to 8 players. If you can have more than that, then this also applies. Basically, we don't want to necessarily have the lanes go on forever. We want them to reset, because eventually they will go off the screen, or they'll be on the edges. We only want it within a pretty reasonable radius here. So we want the players, or we want the lanes to be indicative of basically every player could be respawning at the same time, because it's very possible. Everyone could fall off the map at the same time. But we don't want it to go higher than that. So I take the current lane, I add 1 to it, and I check if that value is less than the players array that we have, which there was all of our player references, length. So players, length. Alright. This is just integer is less than. So we're checking if the current lane is less than the number of players, and if it is, we're setting the current lane to the result of the current lane plus 1. See that? This is current lane plus 1 result, and we're setting that to be the current lane value. So basically, we're adding 1 to current lane. Don't get confused, it's just a fancy way of incrementing current lane. But if it's false, saying that current lane is either equal to or greater than the number of players we have, we want to reset it. That way we can get back to the center. At this point, there's no reason to keep going. You know, you can't have more players respawning at a time than are in the game, so it doesn't really make sense. So if it's false, I just reset the current lane back to 0. Now it's important to note, we're not doing it here, but in the next episode, we are going to be resetting we're going to be taking away lanes as players, they get off the revival platforms. So we will have to make some adjustments to know which spots are open, or if we want to go back and start at the center again when, some players get off their lanes. So we'll figure that out in the next episode. But for now, this should be perfectly fine. And that's pretty much it for today's episode, guys. I know it's a little bit of a weird one because it doesn't seem like something that's necessarily all that important right off the bat. But when you realize some of the issues that could come up and how many players can die at one time, then you notice it's pretty important. So I figured we would cover it while we were on the topic of revival platforms. And you can see how they are random. So that's a pretty cool pattern we had going on there. Anyway, guys, if you had any questions about anything I did in this episode, or if you need any help, please feel free to join the Discord community. I'd be happy to help out and talk about everything that we've done. I'm going to give a huge shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys so much for continuing to support the series and everything that I do. I really appreciate it. If you want to check out some programming live streams or ask me any questions live, then feel free to check us out every Friday at 6 to 8 p.m. Eastern Standard Time, where we work on a side-scroller live stream. And that's all I got for you today, so thank you guys so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, everyone.